Okay, so I'm going to give you 4 examples of Descartes' rule of signs. And what it is used for is to narrow down the possibilities when you are looking for the zeros of a polynomial. Descartes' rule of signs tells us how many possible positive real zeros there are, how many possible negative real zeros, and how many possible imaginary. Now, important thing there is possible and not how many there are, because there may not be the exact number that we find using Descartes' rule of signs, but it gives us the possibilities. With the Descartes' rule of signs, to find the positive real zeros, or the possible numbers, you look at the polynomial exactly how it is, and you start at the front with your first coefficient, and you go down the line. Okay, so our coefficients at this point are 5 and then positive 4. Those are the numbers. And you count sign changes, so when it goes from positive to negative or negative to positive. But as we go down the line here, notice positive and positive, there were no sign changes here. So that tells us that there are 0 positive real zeros, okay? Because it's the same as you do the number of sign changes, there were not any. For negative real zeros, we do P of negative x, which means you substitute a negative for all of your x's. If I were to simplify this, notice anytime I have a squared, anytime I have an even power, that negative is going to change back into a positive. So I really come back to this. Now, one good rule of thumb is when you do the negative real zeros, if you just take the polynomial and anything with an odd number exponent, its sign will change. Okay, then you look at the polynomial, and once again we look for sign changes. I go from positive 5 to positive 4. No sign changes there also. So we have 0 negative real zeros. Then we have to find out how many imaginary zeros there might be. Okay, now this is an odd case. Most of the time you're not going to have 0 or most problems they would give you in a textbook would not have 0 positive and 0 negative reals. But at this point, that's what we have. So positive real zeros, we found there were 0. Negative real zeros, we found there were 0. Imaginary, where imaginary comes in is after you found out how many positive and negative real zeros are possible. And you go for imaginary. And the way that we figure out how many imaginaries there could be, we look at the polynomial's degree. Now notice this is degree 2, okay? So that means there will be 2 zeros total. Whatever your degree of your polynomial is, you will have that many zeros. Now realize some of them could be real and some could be imaginary, but total we need 2. So far I have 0 positive, 0 negative. So to get a total of 2, I would have to have 2 imaginary zeros. Okay, so that's how you figure out how many imaginaries there would be. You see, how many would I need to make the total of the degree? So for this problem, there's 0 positive reals, 0 negative reals, and 2 imaginary real numbers, or imaginary zeros. Okay, here is another example. So again, they want the positive reals, the negative reals, and the imaginary zeros, the possibilities. So for the positive real zeros, again, you look at the original function and you count sign changes. So as I go from front to end, positive 2 to positive 2 is not a sign change. Positive 2 to positive 3 is not a sign change. There were 0 sign changes, so there are 0 positive reals. As far as negative real zeros go, we want to do the negative f of x. So I'm going to take that polynomial, and really what happens is anything with an odd degree, its sign is going to change. Because we're putting negative in for our x, anything with an even degree would come out positive anyways and wouldn't change our sign. But if it has an odd degree, like this 2x to the first power, its sign will change. It was positive, so for f of negative x, it will be negative. And we count the number of sign changes on f of negative x. So as we go down the line, we go from a positive 2 to a negative 2, that's 1 sign change. Negative 2 to positive 3, that's 2 sign changes. So for our negative real zeros, there are 2. Now, when you get above 1, since we have those possible imaginary zeros, and imaginary zeros always come in pairs, in sets of 2. So when you're doing your positive reals and your negative reals, we have to account for the possibility of imaginary zeros. So when you get up above 2, we had 2 sign changes here. You subtract 2 until you can't anymore. So we have 2, or 2 minus 2 would be 0. And what that does is allow for imaginary zeros. Okay, so far, for our positive real numbers, we know there are 0 of those. For our negative real numbers, we know there are either 2 or there are 0. Now we have to figure out how many imaginary zeros there are. And again, to figure out how many imaginary zeros there are, you look at the degree of your polynomial. It's 4. That's how many zeros we should have total between our positive reals, negative reals, and imaginary. And we look at each case individually. So we have no positive real zeros. We could have either 2 or no negative reals. Let's say we had 2 negative real zeros. How many imaginaries would we need to make a total of 4? We would need 2 more. Okay. Then let's look at this case. The second case would be if we have 0 positive reals, because it says we don't have any, and 0 negative reals. Okay, so if we have 0 and 0, if that were the case, how many imaginaries would we need to make a total of our degree, which was 4, and we would need 4. Okay, so our final result is that for positive reals, we have 0. For negative reals, we have 2 or 0. And for imaginary, we have 2 or 4. Okay? So again, you find the positives and negatives, and then to find imaginaries, you look at your degree, and that's the total you'll need when you get your zeros. So now this is why they say it's a possibility, because we could have 2 or 0 negative reals. Just depends on the particular polynomial, and we could have 2 or we could have 4 imaginary zeros. Okay, hopefully you're getting the hang of this. Let's do another one. So again, with our positive real zeros, we look at the original function, g of x, and we count sign changes as we go from front to back on the polynomial. So we go from -3 to -5, that's not a sign change, they were both negative. Then from -5 to +4, that's a sign change. We went from negative to positive. And then from +4 to +3, again, no sign change. They were both positive. So we had 1 sign change. So we have 1 positive real zero. For the negative reals, we write down g of -x, which again, the shortcut for doing that is anything with an odd exponent, its sign will change. So this term here and this term here both have odd exponents, so their signs will change. So g of -x will be -3x to the 4th, and we change this to a positive 5x to the 3rd, and change this to a -4x plus 3. Now we're going to count the sign changes to find out how many negative real zeros we have. So starting at the front, we go from -3 to +5. That's 1 sign change. We went from a negative number to a positive. And then +5 to -4, that's another sign change. And from -4 to +3, that's a 3rd sign change. So for our negative reals, we have 3. Again, anytime you have a number big 2 or larger, you have to subtract 2 until you cannot anymore. So we have 3, or 3 minus 2 would be 1. And again, that's to allow for the possibility of our imaginary numbers there. So our positive reals, we have 1. Our negative reals, we have 3, or 1. And now we need to figure out how many imaginary zeros we would have. So we look at the degree of our polynomial. It's 4. So whatever situation we come up with, we have to have a total of 4 zeros. So we look at this first case. Let's say we have 1 real. That's automatic. Let's say we had the 3 negative reals. How many more would we need to get 4? Well, none, because 1 plus 3 is 4 already. So that would mean we'd have 0 imaginary. But if we go over here and we have the 1 real and the 1 imaginary, how many more, or excuse me, the 1 positive and the 1 negative real, how many more would we need to get a total of 4? We would need 2 more. So for our imaginaries, we have 2 or 0. So our final answer is that we have 1 positive real, 1 negative, 3 or 1 negative real, and we have 2 or 0 imaginary. And that is our final answer there. And again, this just gives us the possibilities. So those we're solving, once we find 1 positive real 0, we know we're done with positives and could move on to negatives. All right, here's one last example. If you've got the hang of it, go ahead and take off at any time. This is just for your benefit. So again, positive real zeros. You look at the original polynomial and count sign changes. Okay, so positive 2, positive 4, no change. Positive 4, negative 3, that's 1 change. And then negative 3 to positive 2, that's another change. Again, we're counting the number of positive to negative or negative to positive changes. So our reals, we have 2. Again, anytime you have 2 or larger, you subtract 2 until you can't anymore. 2 minus 2 is 0. So we have 2 or 0 positive reals. Now let's count the negative real zeros. Again, we want to write p of negative x to count our sign changes. And again, what would happen is anything with an odd exponent, like cubes or first powers, will change their sign. Anything with an even exponent or no exponent or no x at all would not change. Okay, so the only ones that changed were the 2x to the third changed to negative 2x to the third, and the negative 3x changed to a positive 3x. Now we count the sign changes. So negative 2, positive 4, there's a sign change. And positive 4, positive 3, no sign change. Positive 3 to positive 2, no sign change. So there is 1 negative real 0. Now we come down here and figure out how many imaginaries we would have. Okay, well, for our positive reals, we either have 2 or we have 0. Our negative reals, we know we have 1, regardless. So, look at our degree. It's degree 3, so we'll need a total of 3 zeros for each situation. So here, if I had 2 and 1, that gives me 3 already, so I would need no imaginaries. If I come over here, if I have 0, I know I have 1 negative real. Okay, so if I have 0 positive reals and 1 negative real, how many more do I need for a total of 3? I need 2. So for imaginaries, I have 0 or 2. So my final answer down here is that for my positive real zeros, I have 2 or 0. For my negative real zeros, I have 1. And for imaginary, I have 2 or 0. Okay, so hopefully that helps you out, gives you a couple examples of how Descartes' rule of signs works.